Thank you for joining me today. It's Brian Gubernick, and welcome to the No Days Off podcast, where we believe that every single day brings a new opportunity to get better. If you've ever had the opportunity to watch a NASA launch, whether it's on TV or on YouTube or in person, then you probably know it looks like a lot of confidence. Right? It looks incredibly organized and orchestrated. There's a countdown, there's ignition, there's liftoff. But behind that confidence, that level of confidence, that pure confidence, is a whole mountain of math. Before a rocket even leaves the launch pad, NASA's engineers are quietly running something called mission success probability analysis. It's not the thing that makes the highlight reels. It's not the thing that someone's getting interviewed about after a successful launch, but it's actually one of the most, in my opinion, brutally honest tools that can be used in decision making. Here's how it works. NASA breaks a mission down into every single system and every single step that must go right in order to have success. They then assign a probability to each of these systems in terms of their success. So maybe the main engine has a 99.5% chance of functioning exactly as it should. And maybe the guidance system has a 98% chance of success in terms of its operation. The communication system, maybe it's at 97.5%. The landing mechanism, let's say it's at 96%. Now, individually, those rates sound fantastic, almost guaranteed. They're almost 100%. But when you multiply them together, I think that's when the reality actually sets in. Because 4 steps that I just described, all of them in the high 90s in terms of probability of success, when you combine them to an overall mission success probability score, it's actually 91%. When you take 99.5 and multiply it by 98 and multiply it by 97.5, and then multiply it one more time by 96, again, each of those individually really high success rates. But when combined, the actual probability is 91%. If you add more systems, even with the smallest chance of failure, that final number continues to go down. So NASA knows that every extra requirement decreases the odds of the end goal being achieved. When NASA's looking at a mission to the moon or a mission to Mars, they've got to map everything out that's mission critical. The hardware checks, the software performance, the readiness of the crew, weather, fuel transfer, all of the science that I don't understand, like orbital insertion burns. For each of those, they have historical data and they have test results and they have simulations that give them a pretty good idea as to probability of success. They come up with a probability number and then they multiply them. And if that mission has 20 critical steps, each with 99% success probability, the final success probability is not 99%, contrary to what some people may think. It's actually 82%, about 82%. If each of those individually were 95% instead of 99%, that's only a 36% chance the mission fully succeeds. This is why NASA has to obsess over simplifying procedures. It has to obsess over removing any sort of unnecessary steps and then in building redundancy into the most fragile points. Because they understand mathematically that complexity is the enemy of its success. Now, this applies in our No Days Off Nation world as well. Let's say you're running a traditional business sales team. And to close a big account, you need, number one, the prospect to actually take your call, which has a likelihood of, call it 70%. And then once they take your call and you set a meeting, you need the meeting to be productive. That's going to be about an 80% chance for sake of this example. Your proposal to actually be reviewed by decision makers, we're going to put that at 75%. And then for that company to get budget approval from finance, we're going to put that at 80%. And then for the legal department to finalize a contract without any delays and getting it to the finish line, I'm going to call that 85%. So individually, none of those numbers are all that alarming. Again, the odds seem fairly high of success. But when you multiply them all together, those 5 I just mentioned, you end up with 28.56% chance of getting to a closed deal. It's really fascinating to think about. So what do great sales leaders do with that? I think that if I'm in the shoes of this particular sales leader, I've got to look to cut steps wherever I can, because that will increase the probability that we succeed. I'm also going to look to increase the probability of each step through better prep, better systems, whatever it may be. I'm also going to add redundancy, like alternative paths, in case one fails. And see, this is exactly what NASA does. They identify where probability is bleeding out, and then they fix those points first. Let's say in business, you're launching a product. Let's say you're launching a new app. In order to be successful with that new app, you've got to have development finish on time, which has an 85% rate, let's say, and you need a marketing campaign that hits deadlines at 80%. And then you have app store approval without major issues. I'm going to say that's high at 90%. You need early user reviews that are positive, 70%. And then you need funding that arrives to keep the lights on during the launch. Maybe you have a 75%. You math this one out, 32.13% chance of success overall. This is why so many launches actually flop. It's not that any one of those things goes catastrophically wrong. It's that enough small probabilities, like I'm describing here, stack up to crush the odds. So I think smart operators have to simplify and have fewer dependencies and tighter timelines and fewer moving parts. Now let's apply this in the personal world. I think it's awesome to think about this in business. It's equally as important to think about it in life. Let's talk health for a moment, right? Because we love that here as a topic at No Days Off. Let's just say I want to lose some weight. Say you want to lose 20 pounds in 6 months. So you decide that your plan is first stick to some calorie targets on 80% of your days. Okay, that'd be, 4 out of 5 days every week, or however you want to math that one out. That would be you sticking to calorie targets. And then you're going to work out 4 times a week without getting injured. Well, maybe that's an 85% chance of happening. You're going to sleep 7 hours per night, so maybe there's a 75% chance of that happening. You're going to avoid alcohol on weekdays. Maybe there's a 90% chance of that happening. When you multiply it out, there is a 45.9% chance of hitting goal if you don't actively increase any of those probabilities. So again, going back to the NASA lesson here, don't set a plan where all 4 things must happen without fail. Instead, design a program that can still succeed if one of those particular systems I just gave you slips. Maybe weight training counts as a workout or an active hike. Or maybe sleep can be arranged weekly instead of nightly. How about in your personal relationships? And I know I'm beating this to death, but I think this applies in so many places. How about you're planning a surprise anniversary trip, and you want this trip to go perfect. In order for it to go perfect, your partner's schedule's got to be clear. All right, let's say there's a 90% chance your partner's schedule is clear. Then the flights need to be on time. 85% of the time that happens. And then the hotel needs to honor your reservation. Not a high likelihood they don't, so let's give that one 95%. And then the weather needs to cooperate for the main activity. Okay, 80%. Add those up. Multiply those out. There's a 58% chance of perfection. So 6 out of 10 times, your perfect surprise anniversary trip probably works out. But 4 out of 10 times, it doesn't, even though each of those items I gave you individually have really high probability rates. So NASA thinking says, Either one, have backup activities for bad weather, or two, choose a destination with less travel risk, or maybe three, book a flexible hotel that's easy to reschedule. Again, this comes back to simplifying and adding redundancy. And when you do that, the probability climbs. So, what's the core takeaway here? The takeaway is that this is what I would call the math of complexity. When more must happen, where more steps have to occur, the likelihood of success is lower. More must happen steps equals lower odds, no matter how strong each step is individually. NASA doesn't hope for perfection. That'd be silly. They engineer for a higher probability by removing unnecessary steps, by strengthening weak links, and by adding redundancy for critical points. So, here's what I want to challenge you to do this week. I want you to pick one important goal, be it in business or health or personal. And then I want you to write down every single step that must go right in order for you to have success. Now, once you've written down all those steps, assign a realistic probability to each of them. Even if you're just giving me a gut estimate, great. If you have data to support it, even better. But give each of those steps a realistic probability of success. Then I want you to multiply them all together. That number is your real chance of success. Lastly, look at the lowest probability steps. Once you identify them, either simplify them, replace them, or be sure to add a backup. NASA does not launch until their numbers make sense, and you shouldn't either. Fewer moving parts, stronger steps, better odds. I think that's what it takes to be successful. And as an entrepreneur that's always swinging for the fences, I get it. There's some risk involved, no question about it. But I think the smartest entrepreneurs, they look to minimize that risk by going through this process I just described. That's all I have for you today, the No Days Off podcast. Thank you so much for listening. And remember, every single day brings a new opportunity to get better. So let's get after it.